Hi, I'm Eli, CTO of Locks Inc., and I'll be talking about our PAB log processor. We were funded in Fund 7 in the Open Source Developer Ecosystem Challenge. We requested $3,500 US equivalent in ADA for funding a sidecar method to read and process Plutus application backend logs. The most major shortcoming of the PAB is that as a web server, it provides no useful data in response to a request. It either provides an empty unit, the JSON representation here of the Haskell unit is the open close square bracket empty list, or at most the contract instance ID. There is no information about the state of the transaction or the outputs from the transaction or the transaction hashes. These are all things we need at Lux, and many other people need as well to write comprehensive systems relying on the PAB. So the PAB as a system can't give back data on the response. However, it can yield some valuable information in the logs. You can log any value that the endpoint has access to. You're limited to constructing your log strings in a reusable way so that you can have something process them in a repeated way. These log messages can reduce your need to constantly pull systems like Blockfrost or Dandelion when dealing with smart contract endpoints. We learned logging is hard. And ASON, the Haskell module library, makes it uniform, but quite temperamental. Our KPIs were making sure that logs were containing valuable information and that we could move those logs to a usable data source that could act on the verified information. So the hack of the Plutus application backend log processor is that you can run Plutus app containers and output the logs to a mounted volume that is accessible by a sidecar. So in something like Kubernetes, this would take the form of a mounted volume between two pods on one deployment. We use FluentD as the sidecar with custom configuration. We'll talk a little bit about that in a moment. The syntax for configuration of FluentD is a little bit of work, but absolutely understandable. It's basically like a pipeline that you're designing. And the sidecar uses a tail source, so the tail source of the shared log file, and it can limit which logs you retain or which logs you process. It parses those log messages and transforms them into JSON that is then uploaded to MongoDB Atlas. We chose MongoDB Atlas because at least you can spin up free instances of MongoDB Atlas, whereas with Elasticsearch, you'd either have to run it locally or pay for a service to run it, and those can be quite costly. So we created several Docker images for wallet server, node, chain index, Plutus apps. And you might ask, well, why use ours? So we have these three at the top that are public repos, Plutus apps, Cardano wallet, and Cardano node. You might think, well, didn't IOHK or IOG produce some containers already? Well, yes, but the containers are kind of funny. You can't run them as other users. And so we decided to take an approach where there's one user ID and one group ID that's shared among all the containers. That user ID can read and write the Cardano node socket. And so binding to the node socket is important for chain index and wallet server because you need access to the data as it comes in and communicating with the node. And so we needed this to create a sort of uniform ecosystem for all the containers. And our container that's available in our repository for this PAB log processor only uses that same user. So if you're running this on Kubernetes, you really have to place that shared node socket in some directory. We use the /IPC interprocess communication idea location, and we can put it on an NFS server with rewrite many permissions. We created a sample FluentD configuration, as well as adding in the FluentD UI plugin that allows you to create a monitoring dashboard of the logging process as it's happening to make sure that your configuration file is picking up the right log messages and acting on them. And you can also look as it's running, and you can say, hey, is it outputting the correct logs to MongoDB? And here we see, yes, it is. And so we know our log configuration works for our particular log message format, and we do a particular format. So this will be the same for all PAB log messages, where if you use the log info function. Here we have PAB some line number, and here we have a log time. Then both of these are enclosed in square brackets. We have some message about logging tx object, and then we have what the name of the endpoint is that was called, and then we have some JSON that can later be processed by the Ruby. And we do that in the FluentD configuration where you can sort of enable Ruby to process those messages. So the process logs are then uploaded to MongoDB, as you saw, and that's pretty much the entire service. And so it really runs. We're using it in production now, and it makes things a lot easier to summarize our histories of transactions and things like that. So thank you again.